but we are beginning obviously our discussion once more. I'm happy to have you back. Right, the preparatory examinations of 2023 are being discussed in how the examiners across the 9 provinces in South Africa attempted to approach these important subjects for university entry and for the inculcation of the ability to count in general. And universities require mathematics for entry into programs like engineering, medicine, accountancy, etc. Okay, we get started. Yesterday, I gave you a brief homework about these questions, so I decided today to highlight the homework before I look at other questions. I decided to highlight the question from the Free State. I know that is pretty straightforward, but time was not enough for us to discuss the question yesterday, and we decided that we shall obviously look at the question today. Okay, and I gave you as a homework, and so obviously I'm going to be just following up on the question just to make sure that it is all clear, and then we shall be doing a lot of other things. Right, so we are beginning obviously by looking at the question from the Free State province. In the diagram below, Thabo is standing at point A. Here is point A, and on top of building AB, that is actually 45 meters high. This is exactly 45 meters high. He observes 2 cars at C and D respectively. He observes a car at C and he observes another car at D. The cars at C and D are in the same horizontal plane as B. So they're basically at the same level as point B. Right. Right. The angle of elevation from C to A is 43 degrees. From C to A is exactly 43 degrees. Angle of elevation from D to A is 50 degrees. And CAD is actually equal to 69 degrees there. We're looking at the angle CAD. Okay, right. We must be in a position to calculate the lengths of AC and AD correct to 2 decimal places. Right, so we're looking at the length of AC and that of AD. Let's get started. Right, I must have broken the question down into digestible pieces and now looking first at the length of AC. How do you find AC? Right, so this is how you need to write also in the final examinations. So if you look at AC, here is the point A and there is the point C, and want to find the length of AC. But you can see clearly it is part of the triangle ABC. So first we tell the examiner, we're going to work in triangle ABC, right? So if that is the case, we have the side opposite and we want to find the hypotenuse. So we look at the idea of SOHCAHTOA. We look at the idea of SOHCAHTOA. And now if we have the opposite in the hypotenuse, it's the sine function. So we're looking at the sine of 43 degrees, which is opposite, is actually 45 meters. The hypotenuse is actually AC is required. We cross multiply and we obtain AC equals. So if you cross multiply like this, AC will sit in the place of the sine. The trigonometric sign will sit in the denominator, giving us 45 divided by the trigonometric sign of 43 degrees. Okay, so this is exactly what we get here. Right, so from this, you were able to see that this is exactly what we have. So we continue to analyze this here and to get the result that is wanted. And so now if we simplify this, we're able to get exactly 65 comma 98 the meters, right? So in other words, this AC is exactly 65,98 meters, right? And so we have the following. The next thing is we are continuing to find the length of AD, right? How do you find the length of AD? It's done in the same way. So to find the length of AD, we proceed as follows. So in triangle, right, in triangle ABD, right? So in triangle ABD, what do we have? Right. So we have that we have the opposite and we want to find the hypotenuse. Opposite hypotenuse is the sine function. So we have the sine of 50 degrees, which is the opposite, which is actually 45 meters over the hypotenuse, which is exactly AD, like this. Right, from which we have AD is actually 45 meters. We divide by the sine of 50 degrees. So now what is this here? So if you take the 45 meters and you divide by actually the trigonometric sine of 50 degrees, what do we get? So we're able to get exactly 58. 58,74 meters. Right, so we have this one here. It's actually 58,74 meters. So we've been able to achieve this one, and we've been able to achieve the length of the side there. Right, so with that said, we are in a position to continue and get the desired result. So what do we get out of these? So we have got the following corrected two decimal places, and this is to two decimal places, and this is to two decimal places. In science, we say this one is to four significant figures, 1, 2, 3, 4, and this one is also 1, 2, 3, 4. It is four significant figures. You're going to see that at university in science degrees. Okay, next question. Right, so they also said the given information basically is pretty much uniform, as seen before. We need to be able to calculate the distance between the two cars. Right, so the length of CD, how far are the two cars from each other? And the marks are only 3, so way too easy. But now we need to remember something. We got this one to be 58,74. Right, so we got this one to be actually 58,74 meters. Right, and moreover, we're able to get this one to be 65,98. Right, so this one is 65,98 meters, and we just need to find the length of CD over here. How do we proceed to find the length there? Right, so we're gonna clearly, we have the two sides adjacent, they include an angle, we're gonna just use the cosine formula. Right, so we told the examiner we're gonna work in this triangle over here. So in triangle, right, in triangle ACD. What do we get in triangle ACD? Right, so we have the following, right? We have the following. So we have CD squared. CD squared is equal to this one squared, which is exactly 65,98, right, squared, plus, then we have 58,74. We have 58,74 squared minus 2 into 65,98. Okay, let me just move these a little bit further to the left of the screen so that we are in a position to get to write the whole equation in just one line to avoid potential confusion. Right, I know that this is very easy, but this is what the answer of the province of the Free State. Right, so the students were asked to determine this, or you would say CD squared is this one squared, which is 65,98. Right, you square this one here. I'm doing the corrections now of yesterday's exercise. Homework is 58,74. And you square this one minus 2 into 65,98 into 58,74. Right, and then here we put the cosine of the angle, which is exactly 69 degrees. We put in that place, in that position. So what do we then get out of all this? We're able to get that CD itself is actually equal to the 65,98. Okay, you square this. You add to the square of the 58,74. You square this minus 2 into, right, 65,98. You multiply again by the 58,74. Okay, and then you multiply just by the cosine of the last result there. Okay, so you have that. Right, 4,74. And then you have the cosine of the following 69 degrees. Okay, so we have that. Right, so once you get this, then you can be able to get the final result. So what is then the final result out of this? Okay, but first things first, you're able to see that we have the 65.98, which we square. Okay, we add 58.74, which we decided to square as well. We minus 2 times 65.98. We multiply that by 58.74. We multiply that by actually the trigonometric cosine of the angle 69 degrees. And the answer to that is actually 5025, okay, is 5025, the decimal comma 92 square root this way. So we're able to see therefore that CD is 5025,92. Right. So we continue to find the result we desire here. From here, we're able to see exactly what the answer is to this. So we have the 5025 0.92. Like that, we calculate this. And if we find the square root of the 50 to 5.92, you close, you raise it to the power 1/2. The answer is 70.89. 70.89. And the units here is the unit of distance is the meter. So this is the meters. Or it is actually, accurately speaking in mathematics, we then say because it is being estimated. So we're giving this as the estimate of the result. So this is approximately that. Okay, so and that is the answer over there. Okay, next question. Right. Right, I decided to incorporate as well with us the question from the Mpumalanga province. Right, the question from the Mpumalanga province is also an interesting one, and so I decided to incorporate that one. We're gonna work together to solve this particular question, and so now let's get started. Right, in the diagram we have that AD is 3 meters. Right, it's a 3-meter vertical pole with support cables attached at T and A to a point R, which is X meters from the foot of the pole, D. Okay, D is the foot of the pole. D and R are in the same horizontal plane. So D and R are both in the same horizontal plane. Now, T is 1 meter above the foot of the pole. T, here it is, 1 meter above the foot of the pole. The angle of elevation of A from R is theta. Right, the angle of elevation of A from R is actually theta. TRA is alpha. TRA is alpha. So that TR is this. Okay, I decided to make more space available for that question. So we want to show that TR is one. Okay, and I know that this is actually very, very easy. Want to just show that TR is exactly that, and how do we go about doing that? So to go about doing this, which is what the students or the learners from the province of Mpumalanga had to deal with in this year's trials, is to proceed as follows. Right. So in 5.1 is to attempt, therefore, to simplify this question and see what we can obtain from it. What can you obtain from this question? Right. We're able to see clearly that we need to get TR. Here is T and here is R. We need to be able to get the length of this side. But now we need to find the angle here. What is the angle there? The angle there is actually theta minus alpha. So that is the consequence. What we then have here is that we have the in triangle TDR, in triangle TDR. Okay, right. We have already this angle there. We can see that angle T, right? RD, right? Angle T, RD is actually theta minus alpha. Okay, that is what we have. Right. And now, if that is what we actually have, okay. So, and this basically is a given thing, or you can actually start by saying that um, you can start and write a little bit, just one more step here to make it very clear, but yeah, it leads to the same result. You can write the following. So you can write that, for instance, in triangle TDR, or just first, you can look at the biggest triangle possible that they gave to the students of Mpumalanga. I lost you again. I'm so sorry. I'm so sorry to have lost you.
Well, I'm connecting on my laptop because
Oh,
I'm on
yeah.
my phone now and it's getting hot.
Oh, I understand. It happens. Okay, my apologies for just that. But this is recorded, so there's no way that you're gonna lose anything. All the everything that is being discussed is being kept here, is being recorded. So no worries at all with that. But now I was then saying we're looking at the question from the province of Mpumalanga. And now we're then saying we want to find the length of TR. But now we need to first, if we want to find the length of TR, we must work in this triangle here that is at the bottom. Right, so the couple of things that remain important, we do not quite have the angle here, except that I've just written it now in red. So what we're going to then say is that in triangle, we're going to work first in the bigger triangle, ARD. Triangle ARD.
Recording in progress.
Okay, right, in triangle ARD. So we have therefore that angle alpha plus TRD angle, so plus angle TRD is equal to theta. So first we realize that the angle alpha plus this little angle here, TRD, if you add this angle and this, you actually get theta. Why is this the case? Because it has been given that way in the diagram. Okay, right, from which you're able to see that angle TRD is equal to theta minus alpha, so that TRD is equal to theta minus alpha, right? Which is what I've just written here. So now we can then start and then say we have worked in triangle ARD. Now we proceed to work in triangle TRD, right? TRD, right? And so in the triangle TRD, we need a couple of things. But now we need to find TR from it. But also we can see what the examiner said we need to show. We need to show that TR is X divided by the cosine of theta minus alpha. So which means, therefore, we're going to use the cosine function here. So if we use the cosine function of this, so we have the cosine of theta minus alpha. The cosine of theta minus alpha will become the adjacent of the hypotenuse. So the adjacent is x, so the hypotenuse is exactly tr, which means tr is x divided by the cosine of theta minus alpha, like this. Okay, so and this one here is the results. Is the results. Okay, is the result. So, which means we have been able to prove for 2 marks what the students had to prove in the province of Mpumalanga in this year's trials. Next question. Right, the next question is you need to prove that X is that. Maybe I can give you like 3 minutes to try 5.2. Right. So how are you gonna do it? You're gonna try 5.2. Let me know when you're done, and then you're gonna dictate the answer. Are you following?
Uh, yes, sir.
Right. I'm giving you like 3 minutes, okay? And then we're gonna do it together. Please let me
Okay,
know
sir.
when you're done. I'm watching my clock.
Okay, sir.
All right. Okay, I believe you're done, right?
Yeah, yeah.
Okay, well, what did you get? Can you please dictate to me?
So I'm not that. It got so complicated while I was writing.
All right. Okay, that's fine. But it can be done in a few steps. I was just looking at it myself. That's okay because we're just practicing at the moment. So now there are a couple of things. So this one here is easy. because you just need to look at what needs to be proven. You need to prove that x equals this, but the answer has the number 2. And so the number 2 appears there. Moreover, the answer has theta in it, and the theta appears here. So, but now if you look at this triangle, this angle is 90 degrees, and this is theta. We just need to get this angle here. So this must always be 90 degrees minus theta. Okay, right. So this is enough, and we're done with the question. So what do we need right now? We need to realize that we just need to work in this triangle ATR. That's all. Right, so the answer to 5.2 would be that in triangle ATR, what do we have there? So we're going to use the sine rule. Right, so first things first, we see that we need to get TR. So because we need to get TR, we start with the side TR. We divide by the sine of the angle opposite, which is the opposite TR is this one here. Right, so it is the angle 90 degrees minus theta. So you put 90 degrees minus theta. And this equals. Right, next, obviously, you have this, or we're working just in this triangle over here, like this. Right, where this is T, this is A, and this is the angle R there. Okay, so now we have the TR of this, which is the same as 2 over the sine of the angle opposite, which is alpha. The sine alpha is already there. So we are in business now, and we just need to cross multiply this. And now this means we get TR equals 2. And then we have the sine of 90 degrees minus theta divided by the sine of alpha. What is this? What is in which quadrant is 90 minus? Is in the first quadrant, and the sine is what? The sine is actually positive there, but it changes to its co-function using the co-co rule. Right, so the co-co rule says that you actually can change the cosine to the sine function. This is the co-co rule, right? So we have that the co-co rule appears in two places at 90 degrees and to 70 degrees as cardinal angles, or the angles at the poles of the Argand diagram we studied there. So if you have the cosine, you remove the co, and if you remove the co, it becomes the sine. But if you have the sine, you put on the co, it becomes cosine. Here, having the sine, we put on the co, it becomes the cosine of the angle theta. We divide everything by the trigonometric sine of alpha. Okay, this is what we have, and this is what we've got right now. But this is not exactly what they wanted. So we need to just go one step back. Okay, we got TR was this, but TR was written like this. So TR was x over cosine of theta minus alpha. So, but TR is x over cosine of theta minus alpha. Theta minus alpha. Okay, we're done. So in other words, this one here is equation 1, and the bottom one is equation 2. But both of these are the same side of the triangle. They are the same thing, TR. So now, thus, we have that TR equals TR, right? Okay, because TR equals TR, it actually means 2 cosine theta divided by 2 cosine theta divided by the trigonometric sine of alpha is actually x divided by the cosine of theta minus alpha. So we have this. So we move it across to this side here. After we got these, what do we get? So we have got from there exactly 2 cosine theta. We divide that by the trigonometric sine of alpha, which is x divided by the cosine of exactly theta minus alpha. Right, at this point, we can perform cross multiplication. If we cross multiply, it means therefore we have x, which is 2 cosine theta, the cosine of theta minus alpha. You divide everything by the sine of alpha. Thus, we get the result that x is the same as the following. So it is the same as 2 cosine theta, the cosine of theta minus alpha, you divide by the trigonometric sine of alpha. So that's exactly what they wanted from the students of Mpumalanga province. Okay, so, and this is what we got from the province of Mpumalanga. So you note this now, what you do with this, you practice with this, you take this question, um, you try it again. You need to write notes in your separate notebook. It doesn't have to be new, any book, an old book from your grade 11, from your grade 10. You note the question, you note the answer we got, because I'm going to ask you these questions to do them during our discussion to test your understanding. The next question. If it is further given that theta equals this and alpha, calculate the area of ATR by using the formulas. The area of triangle ATR by using the formulas that. Let me give you another 3 minutes to try the area and give me the answer, then we shall do it together. 3 minutes given.
Okay, sir.
All right.
So when they say we should use the formulas in 5.1 and 5.2, does that mean we're going to have 2 separate calculations?
Okay, that's a good question. Does it mean you're gonna have 2 separate calculations? Yes, you'll have about at least 2 separate calculations. I can move back the screen to those questions, to those um, um, formulas that we obtained there. But obviously, doesn't matter. You can use them to cut down on the amount of work, because if we already got those formulas, so the examiner is saying, please just don't waste time. Do not find those formulas again here. What you need to do, just pick them from there and just use them here, than to derive them again, or like to prove them again, because that will be a total waste of time. So yeah, you let me know to move back the screen, because I still have them. Like, we still have this formula in 5.2. Here's the formula from 5.2. It's here, we proved it there. And then we still have the other one in 5.1. Here it is as well. There it is. So we still have those formulas here. So we certainly still have them. Okay. Okay, here's the question again. Yeah, I'm giving you like 2 minutes. Okay, now it's 12 past up to like 14 past. I want to see what area, when you're done with the area, you tell me what area you got, and then we shall do it together to see if that's the right answer or not.
So I'm not really sure what to do.
All right, that's fine. Thanks for letting me know because I'm just testing. Right, so obviously there are two formulas that you need to use here, but the most important formula is the formula about finding the length of TR. There, okay, what is the length of TR? There, it's actually any of these two formulas we got. You can use TR equals this one or TR equals exactly that. So, but we have been given alpha, theta, and alpha, so you can use the first one. TR is 2 cosine theta over sine alpha. So you're able to see that in 5.3, right? TR is the same as 2 cosine theta over sine alpha. So it is 2 cosine theta over the trigonometric sine of alpha. And so what you're getting is 2 cosine of theta. What is theta? It's actually 68,33. So you have 68,33 degrees. You divide these by the sine of alpha. What is alpha? Is actually 28 degrees, and we shall get the result out of this. But now we are interested, therefore, in finding the area of a triangle ATR. So very, very obvious, right? Because you already know everything that we've got, but we first need to get this TR over here, and this is approximately that one. Okay, so if we have twice the cosine, right? So if we have 2 times the cosine of the following, of 68.33 divided by the sine of 28. So this actually is approximately to 2 decimal places 1.57 meters. So
So,
getting
but wasn't the so for this formula it was
2 cosine theta TR is 2 cosine theta over sine alpha, is it?
so was it not for the because are we which formula are we using, sir?
Let me just see what we have. Okay, there are many formulas. Right. I agree. There are many formulas. So you can use any of them. Like you can use this one as well. Like TR is X over this, you know? Okay, but you see the problem with the one that is X for TR, like this one. There's this one that is TR is X over that. But it has X, but now they've given us theta and theta and alpha. So we have theta and alpha. Can we use this one? So this one is also for TR, but it's not good enough because it has X in it. And the X was not quite given. Okay. So, but if you look at this one here, this one I used is much easier. So, but it is telling us that TR is 1.57 meters, right?
So, but didn't this formula have like another part to it?
Let me see. Okay.
Because
Let me
yeah.
see. Okay, let's start here. Okay, because we looked at triangle ATR. Okay, when you look at triangle ATR, we said that TR over the sine of the angle.
Oh, okay, never mind. So I see it. Sorry, sir.
Oh, okay, that's fine. Right. So we got TR is this. I'm just assuming it is necessarily the case there. Okay, because it worked when you used the sine rule like this. We were able to get the right result to be proven, and so we get this. Right. So if TR is 1.57, we are in business now. Then we can easily get the area of triangle ATR. Right. So to get the area of triangle ATR, we already know this side. We just have to get this side here. What is this side there? Okay, this side is very, very obvious. Oh, this angle here is very, very obvious because it's an exterior angle of these. So this angle here is actually the same here. So there are 2 ways you can use to do that because you have already been given alpha. What is alpha? Alpha is actually 28 degrees. So this angle here is actually this plus the alpha, okay? But this angle here is 68,33 degrees. So, right, now you can get the upper angle there, which is this one here is 90 degrees. Okay, this one is 90 degrees minus alpha. Theta, excuse me. So is 90 degrees minus theta is 68, 33 degrees. So what is the answer here? It is 90 minus 33. So it is actually 57 degrees. So that is what we get. So we get this angle to be 57 degrees. Let me see. No. I'm saying 90 minus 68.33. It is 21,67. Right, so it is exactly 21,67. Okay, just note that. So we're going to have 21,67 here. Right, so this one here is actually 21,67. So this is 21,67 degrees. So you have that. You have that. So what do we get now? Now we are actually better placed to get the results. We just need to get this angle here. There are a couple of ways to get this angle there. Okay, because there's this angle and this angle, we can just easily get that angle. What is that angle? It's 180. So this is actually 180 degrees minus 21,67 degrees minus the angle alpha, 28 degrees. Or you can say these is equal to this plus this and subtract from 180, right? So it's the same thing. Right, so you have 180 degrees, we subtract 21.67, we subtract 28. So this is actually 130, 130,33 degrees. 130,33 degrees. So that is the angle there. So if we come here and we substitute this one over here, right? So this one is 130,33 degrees. Now we want to just define the area, so it's obvious now. So in other words, now the area of triangle ATR, area of triangle A. TR is half AP, half ATTR, the sine of the angle included, which is the sine of 130,33 degrees. Okay, so this is what we get. So 1/2, what is AT? 2. TR. TR is 1.57 times the sine of 130.33 degrees. So what is the answer? 0.5 times 2 times 1.57 times the sine of the following times the sine of 130.33, which is 1.20. So it is actually 1.20. Right, and because we're in meters here, it is square meters of the area. Okay, so look at these very carefully and think about the significance of this answer, but that is what we are getting here. Right, so it is actually that. All right, so it is exactly the answer that is needed. And so we are done. We move to the next question, and we're going to practice together and see what we have. Next question. Because they said if it is further given that calculate the area of triangle ATR, and we found it. Okay, the next question is about some graphs. So we're going to practice graphs as well. We have done a lot of the other questions, but we're going to practice together on these graphs. Right, to learn the graphs very well, graphs are easy, but they don't have a lot of work like the triangles. So let's refresh a little bit. We're going to work together now. Sometimes I will allow you to participate and try a question. And now I will give you a chance to try this question. Right. This question is from the Eastern Cape province, or the province of the Eastern Cape. They said sketched below is the graph of f of x equals the cosine of x minus 45 degrees for x between minus 45 and 180 degrees. Use the graph to answer the questions that follow. Write down the range f for the given interval. So we're interested in writing down the range f for the given interval. Okay, I'll give you like 2 minutes because we are in the spirit of working together. I'll give you like 2 minutes to try this question. And then we shall make a plan. We shall do it quickly. Let me give you like 2 minutes because it's like 2 marks. Try it, please, and we shall do it together after this. Let me know, please, when you're done.
I'm done, sir.
Okay, what do you think the range is?
So I said y is an element of real numbers. And then I said I put in brackets 1 and then -1.
Okay. So, okay, what do you think? You said, okay, can dictate it, please? Just want to make sure I have the right thing. 4.1, you did what? You
I
said
said
what?
y is an element of real numbers.
Like this?
And then, yeah.
Okay.
And then I put in the round bracket 1 to -1.
Okay, you put the round bracket. You put 1. Okay, I'm just trying to write what you're saying because I want us to analyze it. Did you put like
No,
this?
so not without the 2. Yeah.
Okay, like that. Okay, yeah, I'm just okay. So normally we start with the negative number. Okay, that's fine. That's fine. We're practicing. We're practicing. Okay, I'm gonna be teasing you from time to time because I want you to learn as we go along, so that you can like practice thinking. Okay, this one is pretty an easy question. But what is key is to look at to identify the range of the given for the given interval. Look at the maximum y value. What is the y value there? It is 1, right? So we realize that y is 1 there. Okay, now here, where does it get to? It gets here. Okay, remember for the given interval, so it's between minus 45 and 180 degrees. So okay, we continue. We continue. So what do we have now? All right. So you see, now the point here is it does not reach -1 quite, you know. So -1 is like a little bit below. The question becomes, what is it there? What is y here? Because y is something. But now y is above -1. So what is it? You get the point?
Yes, sir.
Right. So there's a little bit, that is why it's 2 marks, possibly. Right. So you need to realize that at 180 degrees, it is just something else. So you need to say f of x, because we need to find out what it is here. Because it does not reach -1. It is just, you know. So you need to therefore write the equation because it is defined by this. which is the cosine of x minus 45 degrees. And then we do f of 180 degrees, which is the cosine of, at 180, you want to know what it is, because that is what the range is going to be, because it ranges to this. The range is to move to a point, right? So, which means x is 180 degrees minus 45 degrees. So what is 180 minus 45 degrees? Is what? Okay, we don't even need to subtract the two. Because we can just use the reduction formulae. Okay, right. So in which quadrant is 180 minus 45? It is the second quadrant, and the cosine is what? The cosine is negative there, but we just therefore just write negative cosine of 45 degrees. So it's negative cosine of 45 degrees. What is this? Which is minus the square root of 2/2. You can write like that. Right. So in other words, what we have here, it is minus the square root of 2/2. So we have this. So what is then the range of this function? Right. So clearly the range is all y, which are from the y value, and we start from the bottom to the top. So in other words, it's going to start from minus the square root of 2/2, and then it's going to go up to 1. Like that. Any question? No question, right? We move on. Okay, it was a slightly tricky question. A slightly tricky question, because normally they just in the exams they just obviously state they normally just allow it to be from -1 to 1, etc. That kind of thing. But yeah. Okay, here's another question.
How we-
Please come again.
So why are we not including the 1?
Why are we not including the 1? This one.
Oh, never mind, size. I thought it was a round bracket.
Oh, okay. Oh, you thought yeah. Anyway, it's square. It's like this. I understand. Yeah, square both. Both brackets are square. Thank you for noting that. Yeah, to have been, because it reaches 1. It reaches 1. So we must include both. But it reaches this one. This minus the square root of 2 out of 2 as well. Okay, right. So page below, it's the same graph of the function. And we have these, right? Okay, draw the graph of h equals sine 2x. For x between -45 and 180 degrees on the same set of x's as f in the answer book, indicate the coordinates of all intercepts with the axis as well as turning points. How do we get this one? How do we get, okay, this one is straightforward. What we need to sketch? We need to sketch the graph of h of x, which is the sine of 2x. Okay, if we sketch this one, between -45 and 180 degrees. So we need to just substitute. Like you start as follows. For instance, I'm just going to include 1 point, the rest will be easy. Right, e.g., we start evaluating the function at -45. So we evaluated at -45 degrees. We have the sine of 2 times -45 degrees. Okay, -45 degrees like this, and we close here. So which is the sine of, what is 2 times this, which is -90 degrees. Okay, what is the sine of -90 degrees? We can use a calculator. It's a negative number, negative integer, which is -1. Right, so which means at -45 degrees, you have -1. And then now we do the same, because we must sketch it between -45 degrees and what? And 180 degrees. The sine, now we put 2 times 0. It's 0, sine 0 is 0. Another point is here. At 45 degrees, 2 times 45 degrees is 90. The sine of 90 is 1. We have another point there. At 90, 2 times 90 is what? Is 180. The sine of 180 is what? Is 0. 2 times 135 is 270. The sine of 270 is what? It's exactly minus 1. Next, we have up to 180 degrees. So the sine of 2 times this. 2 times this is actually the same as 360. And the sine of 360 is what? Is exactly 0. Okay, so it remains to just join the points. Okay, tomorrow I'm going to look at how to use the Casio calculator to just do this graph, because you can just use the Casio calculator to draw these here. Okay, now after we got these, this is the graph we have. Right, because they said draw the graph of these on the same, indicate all coordinates of all intercepts with x's as well as the turning points. Right, this turning point has the x value as 45 degrees and the y value as 1. Right, so, but also this graph has a turning point. Here it is 135 degrees and the y value is minus 1. Okay, like that. So this is, okay, the intercept with x is clear here. The x-intercept of the graph is 0 degrees, it is 90 degrees, and so on. And we have drawn these, and here is very easy. But as I said, tomorrow I'm going to look at how to use the Casio calculator to do this graph. Okay, so we continue. We continue. Next question. State the period of h. State the period of h. What is h? It is this one. H is the sine of 2x. So in other words, we have seen that h of x is the trigonometric sine of 2x. What is the period of this? When x is the element of the interval from minus 45 degrees to 180 degrees, what is the period of h? Right, let me give you 1 minute to try that one, because it's just 1 minute. Please, you let me know when you're done.
So I think the period is 90 degrees.
Okay, good. Let's just look at that. And how do we find the period of the function? So to find the period of the function, we take this one here, period. Okay, we're gonna just do it together, because I did not do it myself before. Okay, so I'm just asking the question, so we're gonna see what we get using the right methods. Right, so how do you find the period? The formula for the period is as follows. So it says the period is actually 360 degrees, okay? Because the period of the sine is 360, the period of the cosine is 360, the period of the tangent is 180 degrees. But it is divided by the modulus of the number 2, or the absolute value of the 2. So at this point, so this number 2 reduces the period of the function. Right, so it means, therefore, you divide 360 by 2, so we divide by the modulus of 2, which is exactly 2, and 360 by 2 is 100 and what? 180 degrees. So which means that the period of h is 180 degrees. Okay, note that the period is not dependent on the numbers that are here, you know. The period is, how is the graph transformed from the standard 360-degree period? So in other words, the period of h, right, the period of h is 180 degrees. Why? Because we take 360 and divide by what? By the number 2. You get the point? Okay, so
Yes, sir.
yeah, that's that. So it's even if the examiner would draw the graph between minus 45 and 45, the small p's, the period can still be 180, even if 180 does not appear here. So we calculate it. It's not that it's based on what the graph is saying, because the graph might just be a small piece. They might just draw from here to here, but it might not even cover the period there. Okay, we continue. Use your graph to determine the value of x for which f and h are both increasing. Okay, I'm giving you some small exercises. You'll forgive me, please. I just thought I should give you something to try, so that you can just train your mind. Okay, you'll say, but now these guys asking me to do this, but now this graph is on the other side. So because the f and h, so you must draw f and h here, right? So you remember that the sign is there, 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 there. Okay. This red one is the graph of what? H, like this. So now they're saying use your graph to determine the values of x for which f and h are both increasing. 2 minutes. Let me know, please, when you're done.
Sir, I know what the question is asking, but I'm not sure like how to answer it.
To answer the question. Okay, that's fine, because you're practicing, and I'm trying to make sure that you practice. Even tomorrow during our class, we're going to practice a lot. Okay, right. Obviously we have these and the graphs have been drawn. We read the story above, so there's nothing new. But we're interested in actually determining the values of x for which both these are increasing. So increasing means that they're going up when x is actually increasing. So x now is increasing, and this is going up, and this is going up. They are both going up. And then here, this one is going down, and this is also going down. And this is going down. But here, this one is going up, and this one is going down. So here, they are both decreasing because they're both going down. This one is decreasing, but this one is increasing. So one is increasing, and the other one is decreasing, and the other one is increasing. Here, one is decreasing, and the other one is increasing. So the part where they are both increasing is surely this part here. Okay, so now what is that part? So it means that you can see that they're increasing from minus 45 degrees to 45 degrees. So 4.4. Right, so they're increasing for the values of x, right, from minus 45 to that. But there are a couple of notes to take there. Okay, there are a couple of notes to take there. What is happening to the graph of f? So obviously the whole thing is happening from minus 45. That's the point. From minus 45 to 45 degrees. But here, these graphs are not increasing. So in other words, they are stationary. So both increasing, you must exclude that one, put a round bracket there. And then now come here, you need to analyze what's happening here if the graphs, because if they're turning, if this is a turning point, okay, we can't see because the graphs are cut short by the examiner, but now they want us to reason about what is happening to the graphs here. So at minus 45 degrees, if you put minus 45, it's minus 45 minus 45, which is minus 90. The cosine of minus 90 is what? Is 0, so it's going to be 0. And then, if it's 0, it is 0 indeed. What happens next? So you have like a minus 90. So you have minus 45, minus 90. So at minus 90 minus 45 is the same as what? It's the same as exactly 90 plus 45, right? Which is the same as 135 degrees. Okay, I'm not gonna waste the right lot of time to waste here. So the cosine of 135 is in the second quadrant. I'm just mentioning that. It's in the second quadrant, and in the second quadrant, the cosine is what? Is negative there. So this one is going to be negative. So in other words, this one is obviously increasing. Is rather actually going further down. Okay, is going further down to the negative. And then now, this one, h. It's if you put the graph of h, so okay, and minus that. So the sine of minus 90, what is this? Is the same as, because if you put minus 45 here, it becomes minus 90. The sine of minus 90 is clearly minus 1. It is minus 1. Okay, let's look at what happens next. Like at minus 90. If you put minus 90, it becomes 0. So this is going to become 0. In other words, what is happening is this graph here begins to turn. Because it begins to turn here towards 0. So this one is a turning point. Right. So if this one is a turning point, it means that it's not increasing at the turning point. At the turning point, the function is said to be stationary. So in other words, this one is a stationary point. Stationary point, but also this one is a stationary point. Okay, so this one here is going to be a stationary point for this function because we understand that it's going to go up like this. Okay, something like that. So you have this kind of an interpretation. So as a consequence, therefore, this would determine the values of x for which f and h are both increasing. So this would be the interval there. Next question. Determine the values of x for which the difference between the two functions is 1. Okay, so we've erased one of the graphs. I can quickly draw. We know how to draw already from the previous question. From the previous question. This is the graph of h. Okay, determine the values of x for which the difference between them. So you have 4.5, which is f h. What is f minus h?
So would that be the cos x minus 45 minus the sine 2x?
Yes.
Okay.
So obviously, it would mean that it's the cosine of x minus 45 degrees minus the sine of 2x equals 1. Okay, so we just substituted the actual defining equations of the two, or the defining functions of the two graphs, and therefore, what is the answer to this here? What is the answer to this here? Okay, the couple of things. So you can see that, for instance, here, what is happening here? You have minus. Here, the h is minus 1. So h is minus 1. And then, but the f is 0. And therefore, this one is exactly negative by negative, positive 1. So it is correct. So this is happening at x equal to 135 degrees. Okay, so you have a solution at 135 degrees. And then also there is another solution. Let's see, there's no solution here. Here, the difference between them is 0. Let's come here now. But also here you can see h is the same thing. So we can see, therefore, that these are just the two points. So we have, yes, please.
Where did we get the 0 minus -1?
Okay, it's because the function f is actually 0 at, the function f is 0 at 135 because it has the is the x-intercept of the function So now at this point, what is the y value here? It means therefore the y value is actually 0 over there. Okay, just one sec. So the function obviously continues like this. Right, so at this point, it means that y is 0. Okay, we have this. So we have x. Yeah, so y is 0 here. What is y here? -1 here. What is y here? Well, for this one, y is 0 on the x-axis. We got y together for this one. Here, y was minus the square root of 2 out of 2. Okay. Right, so for example, so at this point, at 135 degrees, y is 0 for f. Because it is on the x-axis, so y is 0. On the x-axis, y is 0. All right, so at 135 degrees, y is 0, and x is and y is what for the other one? This one. Y is -1. So we have -1 here. So what is 0 minus into -1? It is
It's
1.
1.
So it means, therefore, there is one value of x where this one is 0, where f is 0 because it's on the x-axis, it's cutting, it's having its x-intercept. At the x-intercept, y is 0. And then at this point, at the same point here, at 135, the other one is -1. So it is, the sign is -1. So if you multiply these, you get a 1. So there is, at x equal to -45 degrees, at x equal to -45 degrees, we have something similar. One of the graphs, like the black graph, the f function is 0. So f is 0. But h is what? What is h? H is -1 because it is y that is -1 there. So h, y is, the sign is -1. But negative by negative is plus. Because y is 0 here and y is -1 there. So it's 0, but this sign is h is -1. So negative by negative is plus. So you get a 1. But we're interested in where the difference is 1. So there are two values. So one value of x is actually at -45 degrees, reading from left to right. And the other one is x equal to 135 degrees. And that is the answer for 2 marks. Okay. So we
No, sir.
continue. It makes sense, right?
Yes, sir.
All right, thank you. We move on to the next question. We want to obviously practice this. Okay, I'm going to give you a homework now because I planned that we take like 1 hour. We're going to spare the time for tomorrow. You let me know the time at which we can meet tomorrow. Whenever you're free, it can be any time of the day. Just recommend some time for me. But now I planned that we take 1 hour, so we just exceeded by a couple of minutes, which is okay. So this one here, I'm going to give a homework. Like the graph of f is shifted 60 degrees to the left to form the graph of g. Write down the equation of g in the form that for 1 mark. So you're going to look at that one. So yeah, okay. So I'm going to send a video in the next couple of minutes, and then you're going to try and do the graph of f. It's translated 60 degrees to the left. So this is the graph of f, 60 degrees to the left. Write down the equation of a new function we call g after the translation to the left. Okay. But good luck. That is the last question. Okay. Right. So I plan that to take 1 hour. Let me know when you can discuss tomorrow. Yeah. So just have this question. I'm just going to highlight this question. There are many things I'm going to do tomorrow. In view of the provincial supplementaries of 2023, but also in view of the first exam that the Department of Education has set for the June 2023 students. It was written in June this year, and it is always the same as the November exam. It has been my observation of the many years. So we need to also spend some time on the June 2023 paper that was just written in June this year, because it's going to be very similar to the November. They just change a 1 to 2, a 2 to 3, but the structure remains the same. So we need to spend some time on that. We're going to look at the June paper as well. And I'm going to look at other things that as well will be arising, parts of circle geometry to see your ability to interpret circle geometry questions, to find angles, and to conduct and perform proofs of the similarity and proportionality with some theorems in the geometry of circles or Euclidean geometry. I must thank you for joining us. Please let me know on WhatsApp what time is going to suit you tomorrow. It can be as early as 8 a.m. if you're free, 9 a.m. if you're free, 10 a.m. if you're free. Okay, so 12 midday if you're free, that kind of thing. So please let me know what time to you. But thanks a lot then, and goodbye for today.
Bye, so enjoy your evening.
Okay, thanks, and you too. Goodbye.